It's day 84, and we're looking at how to find the domain of functions. So when looking for the domain of a function, we're looking for things that can restrict it in order to find where the function actually lies. So the things that typically restrict domains are radicals, because whatever inside a radical has to be greater than or equal to 0. Also fractions, because the denominator of a fraction cannot equal to 0. And also log functions, because log functions have asymptotes. For example, the natural log function has an asymptote at y equal to 0, which means that the natural log function only exists to the right side of the y-axis. So with this knowledge, we're going to solve for the domain of the function on screen. So first of all, we have this radical over here. And this radical, what's inside it is x minus 1, and x minus 1 has to be greater than or equal to 0. So x then has to be greater than or equal to 1. So now we go one step out, past this radical here, and we have a log function. So anything, because the log function's domain is greater than or equal to 0, the natural log function's domain is greater than or equal to 0, this here, the root of x minus 1, which is what's inside the natural log, has to be greater than or equal to 0 too. So then we have x minus 1 being greater than or equal to 0, because if we square both sides, 0 squared is still 0. So x then has to be greater than or equal to 1. So now we go one step out again, and we have another radical, which now contains the natural log of the square root of x minus 1. So this is a little bit trickier, and I'll show you why. So now we have the natural log of x minus 1 needing to be greater than or equal to 0. So here's where it's helpful to draw a graph. So what we're looking at is where the natural log function lies above the x-axis, because that's essentially what greater than or equal to 0 means. So we're looking for where it lies in this area. So obviously the critical point where it enters into this area is where it cuts the x-axis, and it cuts the x-axis at x equal to 1. And anything to the right of x equal to 1, it'll be in the area, and anything to the left of x equal to 1, it won't be in that area. So now what we're saying is that the root of x minus 1 has to be greater than or equal to 1. So if we square both sides, we have x minus 1 needing to be greater than or equal to 1, because 1 squared is just 1. So x is greater than or equal to 2. So now we have these three restrictions on our domain. And now we need to take the intersection of them all to find the actual domain of the function. So x is greater than or equal to 1 in all of these restrictions. This is the restriction that really places the main restriction, because it's included in all of them. In other words, it's the intersection of all of them. So in interval notation, x is an element of 2 to infinity, and that's inclusive of 2 and not inclusive of infinity. Thank you.